For CI, we need this representation for the series of f prime. So we can do that on a term-by-term basis, the derivative of the terms, and then come up with the summation notation, or we could use the summation notation. Let's show both ways. I would just use summation notation, it would be faster, but I'd like to show both ways. So starting with the term-by-term differentiation. The derivative of 1 is 0, and then we have the power rule, 1 times 1/2 times negative 1/2 times x minus 3 to the 0. Or just minus 1/2. And then the derivative of this term, 2 times 1/3 times x minus 3 to the 1 power. And then 3 times 1/4 times x minus 3 to the 2nd power, etc. Alright, so it's definitely alternating. Minus, plus, minus, plus. This will take care of that. Then notice we have exponent, numerator, denominator, 1, 2, 3, 2, 3, 4, 0, 1, 2. So we can represent that pretty easily. This might be 1, 2, 3, or 2, 3, 4. So this n needs to be 1 bigger than that, and this needs to be 1 bigger than that. And then we just need the indices. So let's check this. If n is 0, we'll have a positive 1 times something to the 0 power, which is 1 all over 2. We'll have positive 1/2. This needs to be a negative 1/2, so let's change that exponent on negative 1 to plus 1 or minus 1. Alright, now when n is 0, we'll have, I'm going to make that a plus 1. When n is 0, we'll have negative 1 to the 0 plus 1, which is 1, so it's a negative 1. When n is 0, we have 1, and x minus 3 to the 0 power is 1, so we have negative 1 times 1 times 1, which is negative 1, all over 0 plus 2, negative 1 over 2. That does give us the first term. When n is 1, we have a positive 2 times x minus 3 over 3. 2/3 x minus 3. And when n is 2, we have a negative, this is going to be 3/4 x minus 3 squared. We've got it. And what if we had just taken the derivative of our summation expression from the previous part? Well, we would have had the derivative of this entire term. We have the constant negative 1 to the nth stays, and then n times 1 over n plus 1, so n times 1 over n plus 1, times x minus 3 to the n minus 1 using the power rule. Notice the exponents do just what ours do. They go up by 1 to the numerator and then up by 1 to the denominator. But now our indices would be a little different. So n would start at 1. So when n is equal to 1, we have a negative 1 over 2 times x minus 3 to the 0, which is just negative 1 over 2. So either of these answers work great. And for C part 2i, there's no work to do. The radius of convergence is exactly what it was before. If the radius of convergence of the original series was 1, then the radius of convergence for the series representing the derivative will be 1. And the second derivative and the integral, the radius of convergence will never change for these types of problems.